Hello friends, so this is the next video in the sequence of DC-DC converters. So in previous short video, we have discussed a simple chopper as a switch and how you get a variable DC output from fixed DC using a power electronic switch was discussed, right? Now in this video, we would like to discuss the basics of DC-DC regulator, right? Now the question comes that what is the difference between the DC-DC regulator and the simple chopper which we had discussed in our last video, right? So basic chopper as a switch, as we have seen, is a simple load. Let's assume it's a resistive load and a switch which is operated very quickly with a frequency as high as 1 to 3 kilohertz, right? So when you operate in this fashion, then you get a variable output V0, which is delta times Vs, where delta is the duty cycle ratio, right? So by varying delta, you can vary the outputs. That is a simple logic. But the output over here is unregulated, as there is no inductor or capacitor filter or anything is there. So whatever output you are getting is having a lot of variation or ripple, and there is it's not smoothed out, right? So basic chopper gives unregulated DC output, and that is not useful for many of the applications. No inductor or capacitor connected here for smoothing out the output current and voltage, right? That's why the next topic which we are going to discuss here is nothing but the DC-DC regulator. So that logic tells me it's also known as DC-DC switch mode regulator. It provides regulated voltage from an unregulated DC voltage. So you have a fixed voltage DC, then you have unregulated DC, and then you have a regulated DC. And the whole arrangement is called DC switch mode regulator. As you see on the screen, the DC, the supply originally, as let's assume the supply is single phase or three phase AC. Then you, through an uncontrolled rectifier, you have a pulsating DC. You use a filter, and then you have a unregulated DC, and then a DC-DC regulator is there, which gives me regulated DC out. Regulation is achieved by a PWM technique at a fixed frequency, so that you get a required voltage. And this is the reference voltage, which provides me the reference that this is the voltage which you want to maintain it as an output, right? So regulated voltage will be maintained as per the reference provided. And of course, the BJT, MOSFET, or IGBT are used as a switch over here also, right? So we'll see the basics only in this video. So there are three types of regulators: buck regulator, boost regulator, and buck boost regulator, right? So buck is a step down regulator or step down converter. Boost regulator is a step up converter, step up regulator. And buck boost regulator can do both step up or step down, right? So you can reduce the voltage, you can increase the voltage using these converters, right? So we'll see each in detail in subsequent videos. In this video, we'll see the basics on which these converters will be discussed. The first basic over here is that when you use a regulated power supply, you use a large inductor in series. Even the devices like the motor are having windings which are having large inductor. So whenever inductance or inductor is there in series with the DC, then you know that it cannot handle the DC, is it not? In a regulator, basic chopper is combined with the inductors and the capacitor to obtain DC output. Now, what is volt-second balance? We assume that the output is in steady state. That means the value of output voltage and output current is stabilized. It is not changing. It is in steady state. And that's why the following principle should hold: that the inductor in a circuit will not support an average DC voltage across it. So in steady state, we can say the integration of VL over the period 0 to TS should be 0. That is for one, you can say, switching time period. The VL and time product should be 0. Sum of VL and time product should be 0, right? Where VL is the voltage across the inductor and PS is the switching period. This means that the product of voltage and time, or area under the inductor voltage curve in one period, should be 0 under steady state or equilibrium. And this principle is known as volt-second balance of inductor. So if we want to understand buck converter or boost converter, we are supposed to understand that the analysis will be in steady state and it observes this volt-second balance principle. And then we can explain the buck converter or boost converter. Right? So before we go for those converters, we are getting the basics of it. So this is the graphical representation of the volt-second balance. Suppose this is the graph of inductor voltage versus time. So this is for T on period, and this is for T off period, and the whole is a switching period. Right? So then V1 into T on is equal to V2 into T off, right? These two areas must be same, or the average area, equal and opposite, right? So the average over this time period is going to be 0. So that is going to be the principle of volt-second balance in steady state or equilibrium. Similarly, for capacitor, there is Ampere-second balance. The capacitor in a circuit will not support an average DC current through it, right? Because there cannot be a DC current flow through a capacitor in steady state. So this is nothing but explained mathematically with the formula integration of IC dt with the limit 0 to DC is 0, where IC is the current through the capacitor and TS is the switching period. This means that the product of current and time, or area under the capacitor current curve in one period, should be 0 under the equilibrium. This is called Ampere-second balance of the inductor capacitor. So here the term will be capacitor. There's a spelling mistake over here. Ampere-second balance of the capacitor. Graphically also Ampere-second balance is explained over here. If this is the current through capacitor and this is time, so the current into time of one period is going to be equal. That is, I1 into T on is going to be equal to I2 into T off. So that average is also going to be 0 over one period, right? So these are the principles based on which the regulated DC power supply is going to work. So in subsequent video, we are going to discuss about buck converter. That's all in this video.